Myself, Dr.Anna Devi, Associate Professor, Department of ECE, Sathyabama Institute of Science and Technology, deemed to be University, Chennai. Today, we are going to discuss an important topic, flash type analog to digital converter. So, first of all, let us know what is analog signal, what is the need for converting analog to digital signal. Most of the real world physical parameters such as voltage, current, temperature, pressure and time are available in analog form. Even though this analog signal represents a real world physical parameter, with accuracy there is a need for converting analog signal to digital signal because there are possibility of noise get superimposed on the analog signal very easily, as well as for processing, for storage and for transmission these analog signals are very tough. So, in order to process, store and transmit this analog signal, it is easy to convert the analog signal to digital signal and then do all these operations, as well as all the digital communication system require this digital signal. So, analog signal should be converted to digital signal and then it should be used as for the digital applications. So, there are various applications which needs digital signal. So, analog signal needs to be converted to analog digital conversion, which is used in various applications like digital audio recording and playback, computers, music and video synthesis, pulse code modulation transmission, data acquisition, digital multimeter, direct digital control, digital signal processing, microprocessor based instrumentation. So, this is the block diagram which represents the basic analog to digital conversion technique. So, it is called as ADC. We are giving an analog signal which is called as VA. In addition to that, you will be having two control lines, one is start and the other one is end of conversion, which is represented as EOC. In addition to all these things, you should have a reference voltage VR, and based on the need, the application which we are going to use, the number of bits of digital signal we can achieve. So, the digital signal is got from our analog signal is equivalent to D is equal to D1 2 power minus 1 plus D2 2 power minus 2 plus as it goes on plus Dn 2 to the power minus n, where D1 is MSB and Dn is the LSB. So, when you come to the classification of ADC, there are two types of ADC, direct type ADC and integrated type ADC. In direct type ADC, there are two types, flash type converter and successive approximation type converter. In today's session, we will be seeing flash type converter. This flash type converter is the fastest among all ADCs. It only takes only one clock cycle for the entire conversion. So, what are the components needed for this flash type converter? Or it needs a high speed comparator and a resistive voltage network as well as a priority encoder. How many comparators we need? That depends upon the number of digital bits we are going to convert. For example, if I am going to convert the analog signal into 3 bits, I need to have 2 power 3 comparators, that is 2 power 3 which is equal to 8 comparators. Similarly, how many resistors I need in this resistive voltage divider network is 2 power n minus 1, that is 2 power 3 minus 1 which is equal to 8 minus 1, which is 7 resistors I need, and only one priority encoder is needed. So, this is the block diagram or the circuit diagram we can see for flash type converter. This flash type converter is also called as parallel converter because parallelly we are able to convert the entire analog signal into digital signal. As just now we have discussed, we need 8 comparator, 7 resistors. Okay, we know the operation of a comparator. Comparator has two inputs. One is given to the plus, other one is given to the minus, that is plus represent non-inverting terminal and minus represent the inverting terminal. So, it has each comparator has 2 input and 1 output, right. The output depends upon the biggest value of plus or minus, that is if the signal is high in the non-inverting terminal, that is the plus signal, the output will be a high signal, that is which is equivalent to 1. If the input is more in negative terminal, the output will be negative, which is a low signal which is equivalent to 0, right. So, that is the operation of a comparator. So, that comparator we have taken, and to all the plus terminal of the comparator we are giving the analog signal, right. So, the analog signal is given to all plus terminal of the comparators, and to the minus terminal we are giving the reference voltage. The reference voltage we should decide, we are going to, it may be 8 voltage or 5 voltage, based on our need we are giving this reference voltage. This reference voltage is not given directly, it is divided into 8 different levels with the help of this resistor. 7 resistors we are using, and by the use of potential division rule, this resistor divides the reference voltage into 8 equivalent parts, and it will be giving that nodal voltage, divided nodal voltage into the comparator. For example, If you see the top of the series resistors, we will be having the reference voltage, and the bottom of the series resistor we are having the ground. So 0 voltage is given to the last comparator negative terminal, and to the first comparator negative terminal we are giving 1 by 8 VR, that is VR into R divided by 8R, right? R and R get cancelled, so it will be 1 by 8 VR. So that we are giving that 1 by 8 VR is given to the second comparator negative terminal. To the third comparator negative terminal, we are giving 1 by 4 VR. To the fourth comparator negative terminal, we are giving 3 by 8 VR. Next comparator, we are giving 1 by 2 VR, and to the next one, we are giving 5 by 8 VR. Next one 3 by 4 VR, and to the top one the reference voltage is 7 by 8 VR, right. So each comparator gets two input now. One is the analog signal, the second one is the nodal voltage or the reference voltage, which is divided by the resistor, which is called as nodal voltage, right. So the comparator compares the two signals, that is analog signal and this reference voltage, and it checks which is more. If plus is more, output will be plus, which is equal to 1. If minus voltage is more, output will be minus, which is equal to 0, right. So thereby we will be getting 8 output from the comparator, either 1 or 0, or a high pulse or a low pulse, right. So that is given to the 8 line to 3 line priority encoder. The role of priority encoder is it chooses which line should be given the priority. That line will be converted to 3 bits. We know the working of normal encoder, right. The priority encoder is if 2 lines are having the high pulse, the priority will be given to the highest value of the line. For example, if the fifth signal and the first signal are high, means fifth signal will be given the highest priority than the first signal. 5 will be converted to digital pulse, which is equal to 101, right. So that is the role of priority encoder. So 8 bits are given to 8 line to 3 line priority encoder. Priority encoder decides which should be converted to digital pulse, and it converts that into digital signal, which is Y0, Y1, Y2, right. So this is the logic of flash type converter. So this is the formula by which we are getting the nodal voltage. As I said, the first nodal voltage will be reference voltage into resistor divided by total resistor. There are 8 resistor, so 8R. V reference into R by 8R. So V reference by 8. Likewise, each nodal voltage will be divided. So this is the logical operation of the comparator. So our analog signal, which will be compared with the reference voltage Vd. So if our analog voltage is more than our reference voltage, output will be 1. If the analog voltage is less than our reference voltage, the output of the comparator will be 0. If both the signals are same, the previous value will be maintained. So this is an example which will be helping us to understand the function of our flash type comparator. So in this example, my analog voltage is 5.3 volts, right, and I have chosen the reference voltage to be 8 voltage, right. So if the reference voltage is 8 voltage, the resistor divides that, so the lower comparator will be given 1 voltage, the 2, 3, 4, 5, 6 and 7 will be given correspondingly to the negative terminal of the comparator. To the positive terminal, 5.3 voltage will be given, right. Each comparator compares this analog voltage 5.3 with the corresponding nodal voltage. When we compare that, the lower 5 comparator gets positive signal, that is positive input is more than the negative input. So the output will be positive for the lower 5 comparator. When you see the top 2 comparators, it will be giving you negative voltage because the negative terminal voltage is more than 5.3 voltage, right. So when we come to the next, this positive and negative pulses are given to priority encoder. So if you see the lower 5 are getting plus, that is high pulse, and the top 2 are getting low pulse. Now priority encoder has to decide which pulse should be converted to digital bits, right. So since it is a priority encoder, and we know that highest bit will be given the highest priority. So fifth is the highest one here. So fifth 5 will be converted to digital bits. So it will be 101 will be our final output. So this is the truth table of flash type comparator. If our analog voltage is between this level 0 to VR by 8, only the last comparator will be giving you high pulse, right. So that 0 only will be given to the 8 line to 3 line encoder. So 0 means all bits will be 0. Next, if our analog signal is in this range VR by 8 to VR by 4, then the last 2 comparator will be giving us high pulse. So last 2 will be 1 1. Out of this 0 or 1, 1 is having the highest priority because it is the highest bit. So 1 will be converted to digital signal 0 0 1. Next one is, if our analog signal is in the range of VR by 4 to 3 VR by 8, then last 3 comparators will be giving you high pulse. So, out of this 0, 1 and 2, bit 2 is having the highest priority, highest value. So, it will be converted to 2, 0, 1, 0. Similarly, if it is in this range, the last 4 bits will be giving us high pulse. Out of this last 4, fourth bit is having the highest priority. So, it will be converted to 1, 0, 0. Likewise, based on the range of our analog signal, the comparator gives the output. Based on the highest priority, the priority encoder gives the digital signal. This is the working principle of flash tape converter. What is the advantage of this flash tape converter is, it is the fastest converter among all the available ADCs. The maximum time is 100 nanoseconds or even less. It is useful with large bandwidth input. The disadvantages of flash tape converter, it consumes high power. Reason is, it is a complex circuit, it has more comparator, each comparator need individual power supply, and priority encoder also is a complex one, and the number of comparators required for this flash tape converter is more. How many converters we need? We need 2 power n minus 1 comparators. So, if you are going for 3 bit converter, we need to use 2 power 3 minus 1, that is 2 power 3 8 minus 1 7 comparator. If you are going for 4 bit converter, we need 2 power 4 minus 1, that is 15 comparators are needed. Designing a single comparator is quite complex. So, designing this much number of comparator is a complex job. Also, the larger the value of the digital bit n, the more complex is the priority encoder. So, design of this circuit is a complex one, that is also a drawback. And finally, the applications of flash tape ADC, it is used in radar detection, it is used in wideband radio receivers, and also it is used in microwave and optical communications. Thank you for watching.